the scope of Aero HD. Okay. So you have a rugged tablet. Okay. You have the main module. Okay. Then after you have an extension cable. Okay. And
the connector is the key.
The connectors and the adapters. Okay. Yeah. So most of the time you are going to use these adapters. Why? Because when you remove the LRU, at the back of the rack, you have that kind of connector. So you connect directly like this, or you can use the extension cable. Sometimes it's very difficult access. Then you plug directly to the back of the rack. Okay. And sometimes, of course, you can also find typical, coax and RF adapters. So you have SMA, you have TNC, which is very frequent, BNC as well, Type C, which is kind of a big BNC, but you can find it as well, and Type N. Type N because this is the output of our module. Okay. So let me show you. You connect the tool to the tablet like this. Okay, so it's a rugged tablet. Okay, so it's good for hangar environment. I mean, if you drop it on the floor, it will work. It's not waterproof, but it can withstand rain or fluid. So it's rugged. So I launch the software. Okay, and I'm going to show you. I have some demo cables, so I can show you on these cables. It's a standard coax cable. So I plug two cables for the bigger length. I have 6 meters here, okay? And I put a load at the end to simulate the antenna. Okay, let's say this is the antenna of the aircraft. So here I'm going to use N to BNC adapters in order to be able to connect to my coax. Okay. And so today we are going to make the test on the A330. Okay. So you have few data to input before the test, like the operator name. Okay, so I will put my name, Thibaut. The station or the hangar, let's say hangar 6. Just for the recall, you know. The aircraft, okay, so I don't know yet the tail number, but I put something, okay. Then you choose the aircraft type, okay. So as you can see today, we have all the Airbus family and Boeing family, okay. So in my case, I'm going to use the A330, okay. Then I choose the system I want to check, okay. So you have the TCAS, you have the ME, the ILS, glide slope, localizer, SATCOM, radio altimeter, of course, FOMAX, this is Wi-Fi.
Do you have HF as well?
HF, we have it as well, and it's HFDR, okay? That's this system. So these data are coming from the ESPM, the Airbus ESPM, Electronic Standard Procedure Manual, okay? We have not invented, it's just copy-paste the official Airbus data. Okay. So the frequency range, the tolerances are already preloaded into the tablet as per as the Airbus data, okay? So yeah, for the example, I can check the radio altimeter. Then you have the two tests. Yes. The first one is VSWR, so it's a frequency test. So we swipe the frequency of the systems, okay? And we check if we are within the tolerance given by the manufacturer, okay? That's the first check. Then we can do a second test, which is called DTF, distance to fault, in order to see all the little spike which can correspond to a fault, maybe. It could be a shield fault. It could be insulation fault, it could be a tie wrap too tight, it could be a bad connectors, many things. Okay, so we will be able to see and locate accurately with the distance to fall. Okay, so let's start with the first test. You are gonna see that's very rapid. So I will first calibrate, okay, because I did the calibration, but maybe a long time ago. So I make the calibration. So I show you how fast it could be. So you take the calibration plug, okay, there is 3 outputs, and you just follow the procedure. It says connect to shorts. So I take the short circuit one, okay, and I will connect.
So calibration, do we calibrate with the cable, extension cable?
Oh yes, it's a very good question. Yes.
No, I mean you can demo like that. I mean,
yeah. But you know what? I think we are going to use extension.
Because all your extension cable, all these cables, the data already inputted, or every time you have to use you calibrate together.
When I do the calibration, if I do the calibration here, the zero meters will be set here. If I use the extension, exactly.
Okay.
So as we most probably will use the extension cable, I'm going to do the calibration right now.
Okay. No, because later the guys who use it will ask this question as well.
Yeah, no, it's a good question indeed. So, okay, and when I do the calibration here, it will take into account all.
So zero starts here.
Exactly.
Okay.
Exactly. So let's start the calibration procedure. So I fully screw in the shorts and I click on calibrate.
This portion is.
So this cannot be calibrated because you see that you have a different.
So that means this portion is accounted for.
But this one is good because we check them, okay? We check them and it has a very low VSWR signature, okay? So it could be considered as good, okay? This is the official radial, you see the radial connector, the same that you have in the aircraft. And this is a high frequency coax cable, very short in order just to have the less signature possible, okay? But we cannot calibrate this because otherwise we will need to add another, so it's impossible. At the end of the day, you cannot do it, okay? So short is done, you see it's very fast. So now I'm following the procedure open.
This is much easier than the unresu.
Yeah, sure. We have.
I use the unresu one.
Yeah.
We have made the thing much more easier, much more smooth.
Calibration function also.
So
but
open.
you have to do it. A lot of things to press.
Open. Okay. Great. Then I can do the last step.
Peter, this will be Zohairi, the lead engineer for the aircraft, because the format of the
And the last step, load. Click on load, and it's finished. So you see, the longest thing is to screw in, screw out. But now it's finished, and I'm going to check this cable for the example, okay, for the demonstration. So, okay. So this, as you remember, this is the VSWR test, okay? So the frequency test. So as you can see, on the horizontal axis, you have the frequency. So we swipe the frequencies, and we check if we are below the tolerance or not, okay? So in my case, my cable is not so bad, so it's below the tolerance. But just for information, because I know the tolerances from Boeing and the tolerances from Airbus, the Airbus tolerance are very, very high. So it means that they are not strict at all. Very permissive, very, very permissive. For information, so you see the limit for Airbus is 3. For Boeing, for the 787, the limit is 1.7. So it's almost 2 times stricter. more stricter because it's actually a logarithmic thing. So I'm a bit surprised of the limit, but this is the limit from Airbus. Okay, so I cannot change it. I mean, or you can put your own limit if you want, but just for information, for Boeing is much more stricter, much more difficult in terms to be, especially for the radio altimeter, because the radio altimeter is important system, of course. So yeah, that's just for information. So here you see that we have some peaks. So you can use this and read the top peaks. You see the top peaks is at 2.4. 2.4 is quite high. It's quite high. Yeah. And from my experience, it's quite high. But anyway, so the higher is it, the bad. Okay. If it's low, if it's very flat, close to the bottom, it's good. Okay, that's how it works. Okay, so you can save, of course, the curve. You can do whatever you want. And I click on test now. So now this is saved, and I can launch the second test, which is distance to fold. Okay, so let's launch the second test. So actually, I will make another calibration because it uses different frequency. You need to do a calibration for the VSWR test and a second calibration for the distance to fold. Okay? Because we are using different frequency range here. Okay, so I'm going to just again do the calibration very quickly. So short.
So between each test, we need to calibrate.
Yes. But this once you've done the calibration for the DTF and VSWR, then after it's okay. So I will not need to do it again later on the aircraft. Okay, it's safe for 24 hours. We consider that for 24 hours the calibration is valid. After that, you can have change on the environment, temperature, moisture, etc. So we need to make another.
Any reason why it's kept at 24 hours?
This is our choice, but you can lower or you can extend. After you can do whatever you want, or you can force to do it every time. It's also a possibility. So if you choose this tool, we will ask you, okay, what kind of calibration limit you want? 24 hours, 2 days, 1 week, or 0. Then the guy will need to do it
Every time.
Every time. Yeah.
Actually, is every time.
Every time. I think it's a bit strict every time. I think it could be because if you have several aircraft in a row.
The Airbus module that we borrowed, it was pre-calibrated.
Pre-calibrated?
They said in the manual, then all calibrated.
Yeah, of course it's calibrated. There is a manufacturer calibration and there is a user calibration. It's two different things. Okay, so let's connect again. So 0 is here, okay? 0 meter. Okay, so that's what we have. So I can zoom in. Oops, sorry. I can zoom in with my finger. Yeah. I continue to zoom in a little bit like this.
Easier than 100 screws.
It's tactile, that's why it's easy. And now we have also a stylus integrated in the tablet, because this is the old one, but now you have the stylus, so it's even easier than the finger. So you have the distance here, okay. So yeah, it's a bit more than 6 meters, and 0 is here. Sorry, it's here. So you have a peak. Because here it's a BNC connector. BNC is not made for such high frequency use on a radio altimeter. In your aircraft you don't have BNC, you most probably have TNC or something. But so that's why you have such high peak right at the beginning, because this is above but this is just for the example, okay? At 1 meter we can see that we have a quite important peak. And 1 meter, if I deploy my the thing here. 1 meter, this corresponds to this. Okay. If you see, if I touch with my finger, the peak is moving. Okay. So that's pretty important fault. Okay. You see that the shield is damaged. The continuity is still good. Okay, but the shield is damaged. So at 1 meter, this is the fault which is here. Okay. Then it's pretty good. Okay, you have some. It's never completely flat, but it's okay. It's okay. At up to a bit more than 3 meters, you have important peak again because it's a BNC. Okay, so you have a lot of reflection. This is not a proper connector for. So it's too high, and clearly too high. You see the limit is 1.15 for Airbus. Okay, you see the limit in red. Okay. Then you have almost nothing, and here actually we have a small peak. It's a bit small actually, but this is it corresponds to this. You see, if I touch my finger, you see the peak is moving here.
Oh, the end one.
Yeah. Okay. Here the peak is quite low because we have so much reflection here. We have so much loss of the signal that this peak. If I put it at the beginning, okay, I'll show you. If I put it at the beginning, it will be much more. Oops, sorry.
Oh, the other side.
Voilà. Put the other side. So I have swap the thing. You see, so that's. Where is it? The other way, okay? At 2 meters, okay? So now the peak is bigger because we have less reflection of the signal, okay? And this one, which was here, is smaller because there is so much reflection, you lost a lot of signal, okay? That's not usual in aircraft. You should not have this in aircraft, hopefully not. And at 6 meters, this is my load, which is you always have a small reflection. In aircraft, you have a real antenna. Okay, you have much more reflection at the antenna level. Okay, at the antenna level, you always have like a kind of messy. So we need to finish. I would say to finish the inspection just before the antenna, and you can do it because all the tolerances are automatic. Okay, so you can do it by changing, you see, range stop. So I will change the range stop at 6. You see my line which is moving. So here we are.
That means you can change the range from even
Yes.
the cable is that long, you can change
Yes.
it to limit to 5 meters.
Exactly. I can change the range. Yeah. If I change below 3 meters, it's gonna be green. You see, now it's green because I have removed all the rest. Okay, and now it applies when you have 2 lines up because now it applies the other tolerance from Airbus, which is it counts the number of peaks. Okay, that's the tolerances from Airbus.
There is.
So here it will say, let me check, max peak. So it counts one peak, which is here actually, okay? One peak in between 1.09 and 1.13, okay? So it will count the number of peaks, okay? And this is not the case for the radio altimeter, but for some other cable. You have sometimes connectors in the middle, and you can add connectors because for Airbus they apply another tolerance at connector level. Okay, so you tell the tool, okay, I have connector here, and it will apply for this area another tolerance just for the connector.